Hi everyone! Welcome back to another edition of Rocks and Water, Truisms from Beyond the Classroom. Today we're going to talk about one of my favorite topics. Shift happens. Yes, you heard me correctly. That's shift as in shift gears or shift your mindset, shift a way of being or doing. And today we're going to specifically focus on shifting into mathematical thinking for instruction. Now, even if you're not an educator, don't worry, you're still going to find value in this short video because we're all teachers and learners. So no matter what your occupation is, I know that you'll find something of value in thinking about shifting your mindset on how we interpret our world with numbers and using math in our daily life. So let's get started. So here we are in our daily life, bombarded with loads and loads of information all the time. And it's our job to use our senses to let all that information in or block it if we need to, and then interpret the data and have it make sense to us, put meaning to it, process it in a way that provides us with the information that's useful and meaningful to us. That is sort of a global way of also interpreting how we take in mathematics as a teacher or learner. So I'm sure you have your own math story. Everybody's got one. Some of them start out quite tragic and end on a happy note, which is how mine started out. And I think a lot of educators can relate to this as well. I think educators typically can strive in language arts and then sometimes struggle in regards to math and the ways that they learned math. So my math story is along those lines. And boy, did math ever make me cry. I just didn't get it. And teachers either got equally as frustrated with me or gave up on me. And then when I went to pursue my desire to become a teacher, it turns out that, well, I scored very high in language arts and not so good in math. And to get myself where I needed to be to enter into the program, let's just call them developmental math classes. And yes, I took 8 of them, but who is counting? To get to the calculus course that was needed to bring me up to par with my professional peers entering the program. But the good news is that last math class was a breakthrough math class for me because I actually learned about using mathematics and equations as expressions. And the whole idea that you could describe a mountain range with math and using numbers was just like poetry to me. So that made a huge impact in my life, and it really also altered the way that I engaged in teaching math as well. And I don't really like to say teaching. I'm just going to say facilitating. I'm just the facilitator for others to sort of discover and notice and wonder and awaken their understanding of math and how to make meaning of the symbols that we use in math. So that's what we're going to talk a little bit more about today. In fact, we're going to look a little closer at the essence of mathematics as a way to make simple things. It's not a way to make simple things complicated, but instead to make complicated things simple. I'm going to let you read that on your own for a second and let that sink in. Can you think of some examples that makes that true? I sure can. Boy, it makes me think of sort of uh, taming chaos in a way. I'll tell you one thing, one daily life thing about taming chaos is loading the dishwasher. Because that can be quite complicated if you're not thinking about how things fit together and categorizing things and noticing their spatial awareness of things, the dimensions of things and measurements and all of that. And you can see where mathematics is naturally embedded into our daily lives if we're available to view them in ways that make complicated things simple. Boy, that's a joyous breakthrough. So I hope that you come away with some of that today. There we are with our complex equations that could make some people quiver just thinking about some of this math. And I wanted to go back to something that I touched on earlier in regards to my own math breakthrough and how it can be mathematics is simply another way to express. And there are mathematical equations that express the essence of things to get to the heart of the matter of things. And so it's really not scary at all. However, if you're somebody who's like me that really excelled in language arts, but not so much in math, you have to shift your thinking into noticing the similarities between the two. And I'm going to demonstrate and talk about some of those parallels with language arts and mathematics that exist in today's schools and practices, not necessarily best practices, but practices in our schools today about how we're teaching and learning, that interplay between teaching and learning with mathematics and language arts. So one of the things I wanted to touch on was in language arts, we talk a lot about fluency. Now, there are some teachers and learners that view fluency as speed because it's measured in speed, sort of that equation that relates to speed and accuracy. I prefer, and we also use that in mathematics as well, to have fluency in your times tables and things like that. I prefer to think about fluency as flexibility, as a way to use in language arts the words that you know in flexibility to help you understand what you're reading, because ultimately the goal is to have comprehension. So it's not about how fast you read each word, because you may or may not be able to understand it. But do you have flexibility in your strategies to help you understand what you're reading? Because ultimately the goal is comprehension. Same thing in regards to mathematics. Mathematical fluency is really all about that flexibility, the flexibility in how you use letters and numbers to help you decode and encode for meaning. That's all it is. Imagine if we took this scramble of letters and used our flexibility to pick out the letters that would make sense to us to create math is fun. But you get what the shift that I'm talking about, I hope, in regards to really this kind of literacy is the same. It's between math and language arts, between using, words as expressions and mathematics as expressions. Because it's that fluency that's going to lead to comprehension that makes it useful and meaningful to the reader and the mathematician. Um, and that's what is really at the heart of mathematical thinking for instruction. It's about having this broader, more global understanding about how we use math in our world, how mathematics is made up of symbols that we interpret that give meaning in their patterns. And just like in reading, where we want to, use our sight words and find words that can help anchor us in moving forward, there's the same thing in math. And in math, in the early years, it's called, using your friendly numbers, knowing how to make a 10. So powerful. Knowing how to use your tens and decompose numbers into those place values to help you deconstruct and construct and computate numbers quickly. And you can do really big things with with your foundational skills. Same thing with a reading. Did you know the reason why sight words are so important for young learners, those first 100 on the Fry word list that have been identified? It's because they make up 51 or over 50% of our written language text. That means that no matter if you are reading a college level book on science, you're still going to have about 50% of those words are the words that you hopefully learned in your primary years. That's amazing. Well, in mathematics, the same thing applies as well. Those foundational skills of thinking about what is inside a number and gaining flexibility with playing with that so that you can get to the friendly numbers to work with and decompose and compose numbers and computations quickly. You've cracked a code that you're going to be able to use when you get to the largest numbers in life. And that's what thinking for mathematical instruction is all about. It's, the content and the standards in mathematics are set, and there's something that can be learned and integrated. But these larger concepts about thinking about the how we think about math and those metacognitive skills in regards to thinking about our thinking. Those are the big global concepts, and understanding that, math is about making mistakes. It's not about getting it right the first time, ultimately. It's about being able, and not seeing them as mistakes, but being able to play with numbers in ways that will help you solve problems, and you might not get to the solution that's correct the first time, but that doesn't mean that it was lost. It's just a way of being engaged in the process of getting to something new that you haven't explored yet. And that's a beautiful thing about math. So I'll give you just a second to take a look at this picture and see what you think about it and see how it applies to our topic of focus today. What kind of notices and wonders do you have? How can you make meaning of this and apply it to a shift in your thinking? Remember, mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. As teachers and learners, engaged in the interplay of using math purposely